Hey guys, so we're going to finish up conditional probability today. So we're going to use the table below to find each probability. So the first thing we're going to do is the same thing I always do, is add up everything together. So let's figure out how many have an associate's degree. So there's a total of 744 who have an associate's degree. There's 1,705 who have a bachelor's degree. 757 have a master's degree. Then there's 1,242 males that have a college degree. 1,964. Now remember, this is in the thousands, by the way. Females who have a college degree. And then that's a total of 3,206. So that's really 3,206,000 projected number of degrees in 2015. So now we're going to find these probabilities. So the first one is the probability that the recipient is male. So that's going to be 1,242 out of the 3,206. So 1,242 out of 3,206. So I pull out my handy dandy calculator, kind of move it out of the way. Make my calculator a little more squat. Make it a little tinier. Okay, so 1,242 divide by 3,206. And I get 0.387, so that's, I'm just going to leave it as 0.387, which is 38.7% if you want to think about it in percentages. Okay, so now the next one wants to know the degree is a bachelor's degree. So we're looking at bachelor's degrees, and I don't have a given. So I'm only looking at my total number of degrees. So we're going to do 1,705 out of the total of 3,206. All right, so I take 1,705 and divide by 3,206. And I get 0.532. Well, it's approximately, it's not equal to. Both of these are approximately's because I rounded. Okay, so this next one has a given. So the recipient is female, given that the degree is a master's degree. So that means I'm only looking at master's degrees, and I only care about the females. So that's going to be 464 out of 757. So 464 divided by 757. And I get 0.613. All right, let's try the next one. It says the degree is not an associate's given that the recipient is male. So this one, we are only looking at males. So of course, I had to choose the pink. And I want to know if it's not an associate's. So I'm going to take my 1,242, subtract the 272 associate degrees, and divide by the 1,242. So I do 1,242 minus 272, and I get 970. And I'm going to divide that by 1,242. So we have 970, so that's 78.781. All right, do you guys have any questions there? How are you feeling? Hopefully you're feeling pretty okay. I've been doing this this is the second day now. Okay, so we're going to make a tree diagram now. And you may not remember stuff about tree diagrams, but we kind of did one on the first day of this unit. It's been a minute. All right, so tree diagrams. A student in Orlando, Florida makes the following weather observations in July. On 78% of the days, the sky was sunny. During the sunny days, it rained 64% of the time. Interesting. During the cloudy days, it rained 87% of the time. So we're going to make a tree diagram. We're going to use S for sunny, C for cloudy, R for rainy, N for no rain. Okay, so we start with sunny and cloudy. That's our first two options. So we're going to come off of this like this. And this is 7.78% that it's going to be sunny. Right? And then from sunny, we have 0.64% rainy. And then if 64% of the time it's rainy, that means that 34% of the time it's not rainy. Okay? So if it's 78% of the time sunny, that means 22% of the time it is cloudy. And then from cloudy, it rained 87% of the time. And if it was cloudy and it didn't rain, then that only happened about 13% of the time. Does that make sense? You can figure that all out by taking 1, subtracting the 0.64. Oh, I put a percentage. I shouldn't have put a percentage. There we go. Okay. So there's my thing. Now, it wants me to, so we have to remember our equations for independent and dependent yesterday, whether we're multiplying or adding or whatever it is. Well, by yesterday, I mean like 2 times ago or 3 times ago. It's from independent and dependent. Go look back at that. So use the diagram to find the probability that the day will start out sunny and then it will rain. So if we start out sunny, that's happening 78% of the time. So this is the probability of sunny and rainy. So this is going to be the probability of sunny times the probability of rain given that it's sunny. Okay, so that makes this pretty easy. This is going to be 0.78 times the 0.64. And we get, if we use a handy dandy calculator, 0.78 times 0.64, we get 0.4992. So that's my answer. All right, on this next one, it's all nice and already written in the format I need. Find the probability of no rain given a cloudy day. So we're only looking at cloudy days. So this is going to be the probability of rain or no rain. Just kidding. So this is going to be, it's exactly the same as the last problem. So we're going to do the probability of no rain, or no, the probability of rainy times the probability of no rain, or no, probability of cloudy, that's what I wanted, times the probability of no rain given that it's cloudy. So we're going to do 0.22 times, oh wait, I'm thinking about this way too much. This is just asking for this, the probability of no rain given that it's cloudy. It's 13. See, even I overthink these things. It's this right here. Dang, overthought that way too much. I hate when I do that. All right, this is the last thing for today. You got this? I believe in you. You totally have got this. Okay. So Miles took a survey of randomly selected students and summarized the results in a table below. Make the table of joint relative frequencies and marginal relative frequencies. So that means we're going to fill out this table right here. Okay. Then we're going to answer the 2 questions after that. So first, we have this. The first thing I do is figure out the totals. So I do 38 plus 14 and I get 52. Then I do 24 plus 24 and I get 48. Well, 52 plus 48 is 100. Oh, that's kind of nice. And then we're going to do 62 here because 38 plus 24 is 62 and 14 plus 24 is 38. Guess what? 62 plus 38 is in fact 100. We did this correct. Good job, us. Okay, and because it's out of 100, guess what? This next part's so easy. This is going to be 0.38, 0.14, 0.5, 0.24, 0.24, 0.48, and then this last row will be 0.62, 0.38, and then 1. That wasn't too bad. That actually worked out real nice. Okay. So if a student owns an MP3 player, what is the probability that the student also owns a smartphone? So we're probability of smartphone. So I'm going to do SP given MP3. Okay, so what this means for me is that I'm only looking at smartphone yeses. And I care about MP3 yeses. So this is going to be 38 out of 52. So 38 divided by 52. And we get 0.73. Well, 0.731. So this is approximately 0.731 is the probability of a person who already owns a smartphone also owns an MP3 player. Okay, if a student owns a smartphone, so this means that we're only looking at students who own smartphones, what is the probability? Are these the same question? Owns a smartphone. What is the probability that the student also owns? Oh, no, this is the other way. But I wrote the wrong one. Guys, why didn't you tell me? I wrote it backwards. We already did this problem. So this is the probability of given a smartphone, they own an MP3. So this one's the probability of given smartphone, they own an MP3, which is 38 out of 52, which is approximately 0.731. Okay. Struggle is real. All right. Now we're going to do the one that I meant to do last time. So this is the probability of a smartphone given the MP3. Okay, cool. So now this is looking at this one. There we go. This is explaining why I'm so confused. Okay, so this time we're still going to take the 38, but we're going to put it over the 62 this time. So then we do 38 divided by 62. And that's 0.613. Oh, that took me forever. And I think that's it for today. That is it. Yay, us. Okay, thanks, guys.